Hi, my name is Ryan and I'm a student in EECS 203 at the University of Michigan. Today I'm going to be talking about big O, big omega, and big theta notation. This is a notation used to express the growth of a function. And so big O notation is defined as f of x, just any function, is big O g of x if and only if there exists two constants, k and c, that are called witnesses to the equation, such that the absolute value of f of x is less than or equal to the absolute value of a constant c times g of x for all x values that are greater than the other witness k. And so what this means is that f of x, the function f of x, grows slower than a fixed constant times the multiple of g of x as x grows without bound towards infinity. So this is like putting a upper limit on the function and saying you're always going to be less than this upper limit. Alternatively, omega notation is the opposite. F of x equals omega of g of x if and only if there exists the same two constants, c and k, also called witnesses, such that the absolute value of f of x is greater than or equal to c times the absolute value of g of x for all x that are greater than c. This is saying the opposite. You're putting a lower limit on the value of f of x. And so as f of x, f of x is going to be growing faster than the c times the g of x. So you can illustrate this with a graph. So if you draw the function x squared plus 2x plus 1, if you draw this function, and then you draw the function 4x squared. The part here in blue is the omega, because this is the lower limit. So this is omega of 4x squared. And then the part in red shows O of 4x squared, because that's the upper limit as you go higher and higher of the equation. So let's show an example of this. Suppose you want to show that 7x squared is O of x cubed. First, one note, the equal sign here doesn't actually mean equals, it's just kind of a representation of the inequality. But to show this, one thing you can notice is that when you have x greater than 7, if you multiply the two sides of this inequality by x squared, you get that x cubed is greater than 7x squared. And these are the two values that you want to show. So it's useful. So this is useful to you. So that what this does is this shows you that if you pick your two constants, if you pick c1 and k as 7, you see that 7x squared will be then your constant c, which is just 1, times x cubed for x greater than 7, where 7 is your k. And so because of this, and this is by the definition, so then you know that 7x squared is O of x cubed. Let's show an example for omega though. So omega is just the opposite again of big O notation. So if you have f of x equals, for example, the function 8x cubed plus 5x squared plus 7, you want to show that this is omega of x cubed. So one really easy function to show this is that you can say that x cubed plus 5x squared plus 7, you know that this is going to be greater than 8x cubed because you have the same x cubed constant and then the extra terms on the left. This is true for all x contained in the positive reals. And so if you choose your witnesses, or your constants as c equals 8 and k equals 0 because x just has to be positive, you see that x, or 8x cubed plus 5x squared plus 7 will be greater than your constant c times your x cubed for all x that are greater than 0. And so because of this, this shows that 8x cubed plus 5x squared plus 7 is omega of x cubed. If you haven't seen yet, there is an important relationship between O of x and of omega of x. So if you say that f of x equals O big O of g of x, and what this implies is that then g of x is omega of f of x. So the two notations are related because if you think just intuitively, is if g of x is like an upper limit on f of x, then if you look at the graph, the g of x will also be the lower limit on f of x. So just that's an important relationship between the two to keep in mind. Now, theta notation is just the combination of the two. If you have f of x is O of g of x, and you have that f of x is also omega of g of x, and you can say that f of x is theta of g of x. So theta is just a combination of omega and big O notation. And so when you talk about this, what this means is that f of x, function f of x, is of the order of g of x, or you can also say that f of x, the functions f of x and g of x are of the same order. This relationship goes both ways, so that if you have f of x is theta of g of x, then g of x will also be theta of f of x. And this is based on the relationship before between omega and big O. So one useful theorem to simplify the kind of calculations of this quite a bit is that if you have f of x equals just some polynomial, x to the n minus 1 plus just any polynomial, a to the 1, x to the 1. So then, what you know when a of n is not 0. What you know is that f of x is going to be of the order x to the n, or is theta x to the n. And so what this does is it simplifies your calculations quite a bit, because you can say that just the highest degree of the function is the order of the function. And so this can make your calculations for finding omega and theta and big O much simpler. So I hope you learned something today, and thank you for your time.